Hello, welcome to this video 3-3 in Essentials of Calculus, and today we're going to talk about the chain rule. The chain rule is a rule for derivatives when you are taking the derivative of a function within another function. Let's go ahead and look at the chain rule. The chain rule, also known as the general power rule, is used to differentiate a function of x that is raised to another power. Okay, imagine a function within another type of function. And I like to go ahead and kind of use the analogy of these Russian dolls here, that Russian nesting dolls that are one within another, right? And so you can envision these popping out of each other, right? You have to open up the outside one, and then another one's inside, and then you open up the one inside, and there's another one in there. Okay, so that's kind of like my concrete example of what the chain rule is. Now here they have a kind of a general power rule here. So they say the derivative of u to the power of n is equal to, okay, so now we're going to take the derivative outside. So n comes down and multiplies with the coefficient. So we have n times u, and then the power drops by 1, n minus 1. But we also have to take the derivative of the inside, or our original function that is embedded there, okay? And that would be u prime, okay? And I'll go ahead and show you a more concrete factor of this. But they say where u is a function of x, okay? And informally, we call u prime factor the hook-on factor, okay? So you'll often hear me refer to this as a hook, or the derivative of the inside, okay? And that's very, very crucial for the chain rule. Let's go ahead and look at an example. So here we have f of x is equal to x squared minus 3 to the power of 2. So f of x is equal to, and here's what I'm going to do. I'm going to go ahead and take the outside and I'll put it in blue, and then I'll take the derivative of the inside and I'll put it in red, just so you can easily see this idea. I want to go ahead and I want to take f prime of x. So I have to take the derivative of the outside. Okay, the outside is the power. It's the outermost part, right? Okay, so I'm going to use power rule. 2 times the coefficient, which is 1. Okay, and what happens to the power? The power drops by 1. Okay, and I still have that inside. That inside does not change at all. Okay, and then now I'm going to go ahead and I have to take the derivative of the inside. I'm going to multiply. Multiply times the derivative of the inside. Power rule gives me 2x. Derivative of negative 3 is 0. So we're done. That is it. There is your chain rule. Let's go ahead and look at example 2. Here I have g of x. And g of x is equal to the square root of 2x squared minus x cubed. Well, I'm going to go ahead and rewrite this from radical form. I'm going to go ahead and put this in rational exponent form. So 3 halves. Okay, 3 halves. That is the outer exponent. And then the inside is 2x squared minus x. Okay, so I just rewrote it. Now I can go ahead and apply the power rule. So g prime of x is equal to, and I'm gonna go ahead and use the power rule. So 3 halves. Okay, and then I'm gonna drop my power by 1. I'm gonna subtract 1. 3 halves minus 1, which is 2 over 2, gives me a positive 1 half. Okay, and I have the inside, 2x squared minus x, that doesn't change. I've taken the derivative of the outside, now I need the derivative of the inside, which is, whoa, I was getting ahead of myself. Power of the derivative of the inside is 2 times 2 is 4x, power drops by 1, and derivative of negative x is negative 1. Okay, and I'm going to put that in parentheses because we have to distribute that. All right, that is it. Pretty simple, right? And here's the main idea that I want you to say with me. Derivative of the outside times the derivative of the inside. Say it with me. Derivative of the outside times the derivative of the inside. Do the hand motions with me too. Derivative of the outside times the derivative of the inside. All right, very essential, okay? All right, let's go ahead and look at a more complicated example. In number 3, we got quite a bit going on here. here? F of x is equal to, let's bust out the colors. Okay, 3x squared. Oh, what's implied here? It's implied that there is a multiplication. Oh, well, when I multiply, we're going to have to go ahead and use the product rule. So let me go ahead and rewrite this function here, and actually rewrite this. I'm going to do 3x squared times, and I'll keep my same color setup going on. I have a 9 minus 4x squared, and again, I'm going to rewrite this. This is a cubic root, so rewrite that in rational exponent form to the power of 1/3. Okay, so you have a chain rule situation going on over here on the right, and on the left, we're multiplying by another function. So we have a product rule here. Okay, so I'm going to use the product rule. I have to because I'm multiplying. If I'm multiplying, it's a product rule. If I have a function within another function, then it's chain rule. So we got both going on here. Okay, what is the product rule? Well, derivative of the first. Okay, so the derivative of my first is 6x, okay, times the second. So that's going to be 9 minus 4x squared to the power of 1/3. Okay, plus derivative of the second. Okay, well, here's where it gets gnarly. I got to take the derivative of the second. So derivative of the second is 1/3, right? I got to take this. Now I got to drop the power by 1, so to the power of negative 2/3. I'm just subtracting 1, common denominator, right? 1/3 minus 3/3, negative 2/3. Okay, so 9 minus 4x squared. So I took the derivative of the outside. Now I have to take the derivative of the inside, which is, okay, derivative of 9 is 0. Derivative of negative 4x squared is negative 8x. Okay, now I have to multiply times the first, times 3x squared, right? So derivative of the first times the second plus derivative of the second, which is this whole big thing here, okay, times the first. And that is it. That is it. You could go ahead, you could simplify all that, but that's pretty gnarly. All right, let's go ahead and now look at what happens when I have a function within another function. So this is the same idea as a chain rule, but you're going to see functions embedded within each other, and they like to give you these problems on the AP exam where they give you lots of information, and it's kind of abstract, and you just have to go ahead and substitute. Okay, it's very, very important. You need to quickly distinguish when am I going to use the chain rule and when am I going to go ahead and use the product rule. Well, a product rule, you have to have multiplication. Chain rule, right? You have functions embedded within each other, okay? And I take the derivative of the outside times the derivative of the inside. They're kind of linked together. That's why they call it a chain rule. Okay, so here is a general setup. The derivative of f of g of x is equal to, okay, derivative of the outside, f prime of g of x times the derivative of the inside, g prime of x. So let's go ahead and look at this example. Okay, if p of 2 is equal to 5, and q of 2 is equal to 3, and q prime of 2 is equal to 2, and p prime of 3 is equal to 4, and q prime of 3 is equal to 3/2, find the derivative of p of q of x at x equals 2. Okay, so I kind of hate these problems. They give you all this junk in the beginning that doesn't really mean anything to you, okay? But you're going to have to use it. The real part of this problem is here. They want us to go ahead and find the derivative of this composition. Okay, so first of all, well, if I want the derivative, let's say, okay, so d dx of p times q of x is equal to, okay, so I'm going to take the derivative of the outside, which is going to be p prime of my inside, which is q of x, times the derivative of the inside, q prime of x. Hey, that was simple. Derivative of the outside times the derivative of the inside. Okay, well now they want what is the derivative at x equals 2. So we're going to go ahead and we're going to evaluate at 2. All right, so I'm going to rewrite this. So d dx of p of q of x evaluated at x equals 2. And that's what that line means, evaluated at x equals 2. Okay, so all I have to go ahead and do is drop in 2 for all this. So p prime of q of 2. So wherever there's an x, we just drop in 2. Very, very simple. Okay, so now what do we do? Well, here's where all of this junk up here is going to go ahead and come in handy. Okay, so let me just highlight so you can easily see the substitution. Okay, so what is q prime of 2? Q prime of 2 is 2. Okay, so I can rewrite this as 2. And what is q of 2? Q of 2. Okay, q of 2 is 3. So I can rewrite that as 3. Okay, so p prime of 3. And now I need to know what is p prime of 3. So p prime of 3, that is 4. Okay, so I can say 4 times 2. So really this problem is what's 4 times 2? And that answer is 8. That is it. Simple, right? Derivative of the outside times derivative of the inside, right? Right there. Derivative of the outside times derivative of the inside. Hey, that's it for the chain rule. Hope you learned something. Catch you next time. Be safe, be easy. Peace.